Black-Scholes model is the most basic model in derivative modeling in quantitative finance. Here, I want to show you one of the derivations of the Black-Scholes stochastic differential equation, SDE. There are a few ways to derive the equation, but here I would like to avoid the more technical ones and introduce the one based on delta hedging and portfolio replication. The basic idea is to construct a portfolio which includes writing or shorting the derivative, for example, a European call option, and allowing delta shares of the underlying. You expect to be able to replicate this portfolio with a simple zero coupon bond. And when time evolves, the change in the value of the bond needs to be the same as the change in the portfolio. In this case, the portfolio is considered delta hedged and effectively riskless since there's no uncertainty, at least for the very short term. Writing down the change in value given delta t, the left-hand side, the bond, changes by pi times r times delta t, where r is the risk-free rate. We can plug in the value of the portfolio since it's the same as the value of the bond. While the right-hand side, we need to derive delta v, the change in derivatives value, in terms of the underlying and time, ds and dt. Assuming the underlying asset S follows geometric Brownian motion, we can use Ito's lemma to differentiate v, which basically is to keep the second order in ds and the last dw, because dw squared is dt, the first order of dt. Now, with delta v expressed in delta s and delta t, we can plug it in the right-hand side earlier. We can now see what delta hedging means here, because the delta s terms here now cancel out, and we now only have delta t terms left. Now, make the left-hand side equal the right-hand side. That is, make the interest rate term equal the value change of the instruments. And reorganize the terms, we have the so-called Black-Scholes equation. Some of you may have noticed there are 4 terms in the equation. The first 2 terms is the interest rate multiplied the delta hedged portfolio value, while the latter 2 terms includes dv over dt, which is time decay of the derivative, or so-called theta, and the fourth term, dv squared over ds squared, which is the second order with respect to the underlying, or gamma. So if you hear people say theta offsets gamma, that's what it means. They go together in a delta hedged portfolio. Okay, hope you find this helpful and hope to see you next time.